Welcome to True Projects. In this video, we are going to explain about a project titled Machine Learning Methods for Attack Detection in the Smart Grid. Introduction of the smart grid system has transformed the conventional electricity network by incorporating the advanced technology and digital communication. While it offers the numerous benefits, the growing complexity and interconnectedness of the smart grid also make it vulnerable to malicious attacks. These attacks can result in significant financial loss and disruption to the grid operation. The goal of this project is to implement the machine learning technique to detect and mitigate the false injection attack in the smart grid system. By analyzing the historical data and utilizing the algorithm like perceptron, KNN, SVM and logistic regression, the objective is to create a robust and precise method. This approach will effectively identify and address the security threat, safeguarding the integrity and reliability of the smart grid infrastructure. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Dataset. In this module, the Smart Grid dataset is uploaded to the application. And the second module is Pre-process the dataset. The dataset often contains the missing values, null values and numeric values which need to be handled before training the machine learning algorithm. In this module, missing and null values are replaced with zeros and non-numeric values are converted into the numeric representation. The dataset is then split into the training and testing set, with 80% of data used for training and machine learning, and for the 20% of data is used for testing the machine learning algorithms. And the third module is Run Perceptron Algorithm. In this module, the perceptron algorithm is applied to the pre-processed dataset. The perceptron is a linear binary classification algorithm that learns a decision boundary separating different classes based on the input features. And the fourth module is Run KNN algorithm. In this module, it involves running the K nearest neighbor algorithm on the pre-processed dataset. KNN is a non-parametric algorithm that classifies the data points based on the similarity to the neighboring points. It calculates the distance between the data point to be classified and its k nearest neighbors and assign it to the majority of the class among those neighbors. And the fifth module is Run Support Vector Mission Algorithm. In this module, the support vector mission algorithm is employed on the pre-processed dataset, and the SVM is a supervised learning algorithm that separates the data points into different classes by finding the optimal hyperplane that maximizes the margin between classes. It is trained on training dataset and used to predict the class of the testing dataset. And the sixth module is Run Logistic Regression. In this module, it involves running the logistic regression algorithm on the pre-processed dataset. Logistic regression is a binary classification algorithm that models the probability of a data point belonging to a particular class. It estimates the parameter of a logistic function to make the predictions. The algorithm is trained on the training dataset and used to predict the classes of the testing dataset. And the seventh module is Upload the test data and predict the attack. In this module, using the uploaded data of the application and the trained machine learning algorithm will predict whether the test data represents a normal state or contains an attack in the smart grid system. And the final module is of Performance Graph. In this module, it involves the plotting a performance graph that compares the performance of all the implemented algorithms. This graph helps to visualize and compare the accuracy, precision, recall and F-score of each algorithm, providing the insight into their effectiveness in detecting the attack in the smart grid system. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder consisting of dataset and the test dataset. And this is the dataset link. And The smart grid attack is a Python code file, and this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Smart Grid Dataset button. By using this button, we are importing the dataset from the dataset folder and clicking this dataset and click on Open button. Here we can see the screen of dataset is loaded, which consists of 527 rows and 129 columns within it, and where we can see of it consisting of both the numeric data and non-numeric data too. But the machine learning model only considers of the numeric data. For this, we need to pre-process the data and change the non-numeric data to the numeric data, and then click on Pre-process Data button. Here in this screen we can see that non-numeric data is converted into the numeric format, and total number of records we found in the dataset is of 527, and these records are divided into the training and testing part, where the training part is of 80%, that number is of 474, and the testing part is of 20%, that is 53, and then click on Run Perceptron Algorithm button. Here, the perceptron algorithm is generated on the pre-processed dataset, giving the accuracy of 48% and the precision of 22%, recall of 50%, and F-score of 31.1%. And then click on Run KNN algorithm button that need to be generated for the pre-processed dataset. The KNN gives the precision of 100, recall of 100, F-score of 100, and accuracy of 100. And then click on Run Support Vector Mission Algorithm button. Here, the support vector mission is generated for the pre-processed dataset, use and precision of 22%, recall of 50%, F-score of 31%, and accuracy of 45%. And then click on Run Logistic Regression button. By this, the logistic regression model is generated by the pre-processed dataset by giving the precision of 22%, recall of 50%, and F-score of 31%, accuracy of 45%, and then click on Detect Attack from Test Data button. By this, we are redirected to the dataset folder, and we need to select the test data from this folder and click on Open button. Here, we can see that the data present between of square bracket is to be of test data, and it is predicted as attack observation is detected, and for some data it detected as attack observation only, but for some information it gives of no attack observation is detected. And click on All Algorithm Performance Graph button. By this, it gives a bar graph where the x-axis represents of the algorithm we used in this project, and the y-axis represents of the value assigned for the each metric for every algorithm. Here, each bar represents of each metric, where blue bar represents accuracy, orange bar represents of F1 score, green bar represents of precision, and red bar represents of recall. And then close this graph. In this way, we can attack the detection by using the machine learning method in the smart grid. Finally, the conclusion is by utilizing the machine learning methods, this project has demonstrated the effectiveness of detecting and mitigating the attack in the smart grid system. The integration of algorithms such as perceptron, KNN, SVM, and logistic regression enables the accurate identification of the false injection attacks, enhancing the security and reliability of the smart grid infrastructure. The finding emphasized the importance of machine learning in safeguarding the critical system against the malicious activities.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Projects YouTube channel and subscribe.